I had a session earlier today with somebody doing the same thing. And
Okay.
kind of have to start with the general formulas. In other words, what you're into now is conic sections.
Okay.
Okay?
Yeah.
There's four kinds of conic sections. There's parabolas,
Mhm.
circles, ellipses. Here, I'll draw them. Parabolas,
Okay.
circles,
Mhm.
ellipses, and hyperbolas. That's what
Okay.
conic sections are.
Okay.
Now, the parabolas you're pretty used to. You've been having parabolas for a long time. Y
Mhm.
equal x squared, right?
Right.
Most basic parabola with its vertex at the origin.
Okay.
Okay?
Mhm.
If you look at the general vertex format for a
Mhm.
parabola, if you remember, it's this, right?
Okay. Right. Oh, my voice is cracked.
Where H and K represent the vertex. And the one I drew, H is 0, K is 0, and A is 1. So you end up with Y equal x squared.
Okay.
Okay? Now,
Mhm.
there's other properties about parabolas that are a lot more interesting than just the fact that it's a quadratic. And
Mhm.
that is, every parabola has a focus, some point
Okay.
right there, and an imaginary directrix.
Okay.
And the directrix is always, this amount here is P, and
Mhm.
this amount here is P. So the distance from the vertex to the focus is always the same as from the vertex to the directrix.
Okay.
And in fact, the definition of a parabola is the locus of all points that are equidistant. In other words, if I take a point up here on the parabola, well, that distance from the focus to that point is the same as that distance. No
Mhm.
matter where I'm at on the parabola. And notice that at the very bottom, clearly that distance is P, that distance is P. But if I'm up here somewhere, then that distance is identical to that distance. And that really is the definition of parabola. Okay? It has to do with these two things called focus. Now, why is the focus important? Is because it turns out that if you're collecting rays from like a distant star,
Mhm.
all of these incoming rays bounce off the parabola, and guess where they bounce to? Exactly that. Doesn't matter
Okay.
where they come in. If they come in here, they bounce to there. They come in over here, they bounce to there. They come
Okay.
straight, they bounce to there. So, and it works in reverse. In other
Mhm.
words, if you look at flashlights, they always have the outer shell is parabolic. And
Okay.
guess where they put the bulb? They put the bulb right there. Because all of the light from the bulb flows out in all directions, but that light hits there and then goes straight out. In other words, it goes out parallel to the vertical axis,
Mhm.
always. And so what it does is it focuses and concentrates the light. And that's why a flashlight works much, much better than if you just had a plain bulb. You know, a plain bulb that was not surrounded by a parabola would be shedding light in all directions.
Mhm.
The reflective parabola is what focuses it and causes it to go out in a single direction only. And
Okay.
all conic sections have these beautiful properties, these strange reflective properties.
Mhm.
And that's why conic sections are really so important, whether they're circles, parabolas, or whatever else.
Okay.
I want to confuse you just slightly more,
No problem.
and they change the format. They could just tell you that A, and maybe they do, some school systems do, A is equal to 1 over 4p.
Mm-hmm.
They either tell you that or they give you a completely new format. If A were equal to 1 over 4p and I multiplied both sides by 4p, I would have this. 4p times y, I'm going to subtract the k before I do it,
Mm-hmm.
equals x minus h squared. So this is kind of the standard format for parabolas.
Okay.
Notice how it differs, but not by a lot. I mean,
Mm-hmm.
move the k to the other side, and if a is equal to 1 over 4p, then I move the 4p to the other side also. So you end up with this and no a. Now,
Okay.
why do they use this format? Because their most important thing is to figure out p.
Mm-hmm.
In other words, they're trying to figure out where the focus is and where the directrix is. So if I start with this format, then it's all I have to do is solve for p, and I have my distance to the focus. Whereas if I go up here, I could solve for a and then figure out what p is based on this, but they do it this way.
Okay.
Personally, I would prefer this way, because then you only have to learn one general format for the equation.
Mm-hmm.
There's another kicker here, and that's that so far in math, you've only had to deal with parabolas that either opened up or opened down.
Right.
Well, with conic
It's not the
sections,
same
you
case for
also
us.
have parabolas that open to the right or open to the left.
Mm-hmm.
Okay, these kind of parabolas are not y equals x squared, they're x equal y squared. Notice the difference. The y term is the squared, the x is not squared.
Mm-hmm.
Okay, so you really have two general formats for parabolas. This is one, I'll put a 1 next to it. That's for vertical, let's put a v. That's for
Okay.
vertical parabolas. But if I want to talk about horizontal parabolas, then I put my 4p in front of the x minus h, which is not squared, and I put my y minus k over there and square it. In other words, your 4p always goes in front of the variable that is not being squared. It's one way to remember it, and that's
Okay.
horizontal parabola.
Okay.
Okay? That's the basics. Now let's look at these problems.
Okay.
Oops, hold on.
No problem.
I guess I have to do this again here.
Mm-hmm.
Snap left. Okay. And you said the evens, odds, which ones?
Just the odd. So we can just do 13 through 17
All right.
on this page.
So, am I reading that right? 1/8 x squared?
Yep, exactly.
Okay. Well, here's this. Is this a vertical or a horizontal parabola?
This would be a vertical.
Correct, because the squared term is the x term.
Right.
Okay. So now let's write the standard format.
Okay.
4p times, well, clearly k and h are both 0, right?
Yeah. Is that because that's where the origin starts?
K and h are where the vertex is.
Okay.
Okay, well, this doesn't have a k and an h, because all this has is 4py equals 1/8 x squared. Well, that's a positive number, so I know it's a parabola that opens to the right.
Okay.
Oh, excuse me. It's a parabola that opens up, like this. What you have to do is take this and get it into this format. What would I do to get it into that, not that format, but this format? Sorry if I'm being a little confusing here.
No, no worries.
In other words, if I want this function that they gave us, y equal 1/8 x squared, to look like this, what do I have to do? What can I do to this function to get it looking closer to this format?
Multiply it.
By 8, right?
Yeah.
Okay, so if I take this function, multiply it by 8, now I have 8y equals x squared. Now, that's awful close to this format.
Right.
What's p? If 8y equals x squared, and my format is 4p times y equals x squared, what's 4p equal to?
Then 4p would be equal to
8.
So you just do the...
In other words, I want the coefficient of y, once I get x squared all by itself on the right, whatever my coefficient of y is equal to 4p. Well, in this case, the coefficient of y is 8.
Okay. So you just...
So p is equal to 2. What that means is that it's a distance of 2 from the vertex to the focus.
Okay.
And also, since h and k were both 0, what are the coordinates of the focus? In other words,
0, 2.
Well, no, 0 what?
0, 2.
Yeah.
Okay.
When they say identify the focus, directrix, and axis of symmetry, that's what they want, is a set of coordinates for the focus. The focus is a point.
Okay.
What's the equation of the directrix? Now, the directrix is a line. What's the equation of that line? Horizontal lines are always y equals?
X.
No.
Or y equals...
minus 2. Remember, the directrix is always the same distance from the focus or from the vertex as the focus is. So if it's 2, if p is 2, then the directrix is 2 units below the vertex.
Okay.
Puts it at minus 2.
Okay.
And the directrix is always perpendicular to the line of symmetry. What's the line of symmetry? What's the equation of that line? When they talk about a line of symmetry, they're talking about the line that makes this thing symmetrical about that line.
Right.
What would the equation of the line of symmetry be?
Would it be x equal 2?
Not 2.
1.
0. 0.
Is 0.
X coordinate is 0 here. And that's all I'm doing is drawing a vertical line of symmetry through the y-axis.
Okay.
Because the vertex is at 0, 0. In other words, this point right here is 0, 0.
Okay.
So the line of symmetry is always going to be the y-axis when you're looking at a parabola like that.
Okay.
Okay. Now, if it was a parabola like this, what's the line of symmetry? That line right there.
Right, which is 0.
No. Remember, a line is an equation of a line. 0 is a point.
Okay.
It's y equals 0 is the equation of that dotted line. In other words, the equation of the x-axis is y equals 0.
Mm-hmm.
The equation of the y-axis is x equals 0.
Okay.
Okay? You can see why this is the line of symmetry.
Mm-hmm.
And why in a vertical one, if I had one over here, well, this is the line of symmetry. So whatever the x-coordinate of the vertex is the line of symmetry. That's what they're asking about when they ask about the axis of symmetry of the parabola.
Okay.
Okay? All right. Let's go on and do 15.
Okay.
Here we have x equal, what is that, minus 1/20th?
X is equal to 1 over 20. Oh, no, I'm looking at the wrong one, my bad. So it's x equals minus 1 over 20 y squared.
Okay. Again, we don't have any k, we don't have any h.
Mm-mm.
And this one we have an x equal y squared. So the first thing to determine is this vertical or horizontal?
Horizontal.
Is it open to the right or the left?
To the left.
So it's going to look something like this, right?
Right. And you just start at the origin 0, 0?
Yes, and the vertex. In other words, when you say start, yes, the vertex is at 0, 0 because h and k are 0 and 0. In other words,
Okay.
this is not y minus 2 squared. This is not x minus 3.
Mm-hmm.
In other words, h and k are both 0 here. So
Okay.
this is our picture. Now, what's the general format for a horizontal one? This is what you always need this next. In fact, once you determine that it's horizontal, now you can write it. You have to determine whether it's vertical or horizontal before you can write it. Remember that the 4p goes with the letter that is not being squared,
Okay.
which in this case is x.
Okay.
So that's the general format for a horizontal parabola whose vertex is at the origin.
Okay, that makes, okay.
Okay. Now, if this is the general format, convert that to make it look closer to this. What do you have to do?
4p parentheses minus 1 over 20.
Now, convert the original parabola, make it look like this format. Well, the first thing you got to do is make the y squared all by itself. How do I do that?
Let's find square root, right?
No, I want y squared by itself. In other words, in the general format, y squared is all by itself, right?
You would divide, right? Or,
Multiply both sides by minus 20.
okay.
Right now, y squared is being divided by minus 20.
Okay.
I see you make this mistake quite frequently where it's like you don't realize these are the same thing.
Yeah.
That is exactly the same thing as this.
Mm-hmm.
Okay? Well, if I look at it like this, the y squared is being divided by 20. To get rid of the 20, I got to multiply by 20.
Okay.
Your tendency is to look at this and want to divide by 1/20th,
Mm-hmm.
which is the same as multiplying by 20.
Mm-hmm.
It's just easier to look at it as doing the opposite of what it's currently doing. Currently, it's dividing into y squared. So to get rid of it, I got to multiply by 20. or in this case, minus 20.
Okay.
Okay? So, if I multiply this by minus 20, what do I get? What's the left side?
So it would be... Would it just be...
You want y squared on the right, all alone. So in order to get that, I multiply both sides by minus 20. What do you get when you multiply the left side by minus 20?
Well, just 4px over 20, right?
Forget the 4p for a moment.
Would just be 4 times 20?
No, I'm going to multiply both sides by minus 20. Well, the left side now says x. If I multiply it by minus 20, it now says minus 20x. Do you see that those two are the same?
Okay.
You see why?
Yeah.
You have to see that. In other words, we can't really go any further until you see why that's the same. That's great algebra.
Okay.
In other words, I'm getting rid of the coefficient of y squared because I want the right side to be just y squared. I don't want it to be 1/20th y squared or negative 1/20th y squared. I want it to be y squared. So I got to get rid of this. Well, the way I do it is multiply it, and that gives me minus 20x equal y squared.
Okay.
That's the equation of our parabola right there.
Okay.
Now, compare it with the general equation and tell me what p is.
That's where I'm stuck, like.
Well, hold on. Here, let me help you.
Okay.
I got y squared over here, y squared over here.
Right.
X there, I got x here. I got 4p there, and I got minus 20. What has to be true? What's 4p got to be equal to?
Minus 20.
You got it. That's the leap that you have to make. In other words, I've got it in the format that I want it in. I've got it as 4 times some number times x equals y squared. Well, now I can solve for p. That's easy. P is minus 5. And notice that that's left 5. So the coordinates of this point are what?
So the coordinates of that point would have to be minus 5, 0. Okay.
Now, the directrix, well, let's talk about line of symmetry because they ask about that also. There's your line of symmetry. What's the equation of that line?
Y equals x.
No.
Or y equals,
The equation of a horizontal line that goes through 0.
Yeah, it's y equals 0.
Okay.
Yeah.
That's the equation of the axis of symmetry. Now, Directrix always runs perpendicular to the axis of symmetry, and it's always outside the parabola. So the directrix is going to be some vertical line that, what's the equation of that vertical line?
X is equal to 0.
Is it 0? 0 is back here.
No, yeah.
How far away is that directrix from the vertex?
5 away.
So what's the equation of that line?
X equals 5.
You got it.
Okay.
So the 3 answers are identify the focus. The focus is right there at minus 5 comma 0. Identify the directrix. That's x equal 5, the vertical line, the vertical dotted line. And identify the axis of symmetry. It has to be a horizontal line. It's y equals 0.
Okay.
Okay. So that's the way we're going to do all these problems, is we're going to start with the general equation. Well, first of all, we're going to figure out whether it's vertical or horizontal, because it's a different general equation for each.
Okay.
Okay, in other words, the horizontal ones is going to be an x equal y squared. The vertical ones is going to be a y equal x squared.
Mm-hmm.
Okay. All right, so let's look at 17. Y squared equals 16x. Horizontal or vertical?
Well, this one would be vertical because it's y squared, right?
No.
Or no, this would be,
The way to remember it,
oh,
Dylan, is to think about what's the equation of one of these vertical parabolas like this.
um, y equals x squared.
Okay, so that's vertical, y equal x squared. You always should remember that because that's what you've
Oh,
worked with for 3 years.
right.
So this is different. This is x equal y squared. That has to be
Mm-hmm.
horizontal.
Okay.
Okay, now give me the general format for a horizontal parabola.
For horizontal, would it be x equals y squared?
Remember, there's always a 4p in front of the,
Or yeah, right. So it'd be 4px time is equal to y squared.
okay? How far away are we from that format with our function here?
Um,
Pretty close, right?
yeah, yeah.
What's p?
16.
No,
No, that's
that's the coefficient of x. That's 4p is 16.
right.
So what's p? If
So p would be,
4p equals 16, p equals 4.
oh, that makes sense. So you're just plugging them in.
Exactly. I'm equating 4p with whatever coefficient I have in front of the x, as long as that's y squared. In other words, I
Okay.
don't have to do anything to get rid of anything this time. They didn't put anything over there. Because all they did was they gave me a coefficient in front of the x, which is actually closer to the general format.
Okay.
Now
That makes
what
sense.
I do is I take my 4p and equate it to the 16. And it's really that simple for something like this. Now let's
Mm-hmm.
make sure we do one more at least here. We got 3 minutes, but we'll do 19.
Okay.
All of these are relatively straightforward in that they're all with a vertex at the origin.
Okay.
Notice I don't have any x minus 1 squared. I don't have any y minus 2s or y plus 2s. So if there's no numbers being added to the x's or the y's, then it's at the origin. It's vertex. Is this vertical or horizontal?
This one would be, well,
What's the equation of a parabola that you've worked with for 3 years?
y equals x squared.
So what is this one?
So this one would be vertical
Okay.
because the x is being squared.
Right, exactly, and the y is not. If both of them are being
Okay.
squared, it's a ellipse. But if only one term is being squared, then the difference between horizontal and vertical is which term. So now give me the general equation of a vertical parabola.
So just the general equation.
Huh?
Um,
And starting with every time.
y equals x squared.
Well, there's always a 4p in
Or
front of
4p. Yeah, I keep
there
forgetting
in
that.
front of the term that is not being squared. So is this y
Yeah.
or x?
So it's 4px is equal to y squared.
Which variable is not being squared?
The y.
That's what goes there.
4py is equal to x
4p
squared.
always goes with the variable that is not being squared. So here's my standard, right?
Uh-huh.
Okay. Let's manipulate this equation so that we have something that looks like this. Well,
Okay.
one thing I can see looks like this is that I got x squared all alone on the right side.
Mm-hmm.
So let's go about trying to do that.
Mm-hmm.
How do I manipulate this equation so that I get x squared all alone?
You divide, or yeah, you multiply the other side by,
Not multiply. These things are being added.
um, Well, you would subtract 3y.
Well, let's subtract 6x squared.
Okay, to
And
get
I'll
it on
show
the other
you
side.
why. It makes it a little simpler. It's closest to the format as I can get.
Okay.
Okay? In other words, my format, the x squared's on the right side. So let's try to get x squared on the right side. Now what do I have to do to this equation to end up with x squared alone on the right side?
You would, well,
Manipulate this equation so that you end up with x squared only on the right side. How do I do that?
right.
How do I get
Divide
rid
by
of
minus
negative?
6.
Yeah, divide by -6.
Okay.
Okay? Now here's
Mm-hmm.
what I have. I'm going to write it down below here. I have minus 3/6 is -1/2
Mm-hmm.
y,
Mm-hmm.
and on the right side I have my x squared.
Right.
In other words, my goal is to make it look as close to this as possible so that I can equate 4p with whatever coefficient I have in front of the y.
Okay.
So what's the next step now?
And then we would, oh,
Our goal is to solve for p.
right. So we would do, um, -1/2 is equal to 4p.
You got it.
Okay.
Always the step. In other words, once you get this looking as close as you can to this,
Mm-hmm.
which is to say x squared all by itself on the right,
Mm-hmm.
and some number in front of y on the left.
Mm-hmm.
Well, once you get it like that, then you take that number and equate it to 4p, and that allows you to solve for p.
Okay.
When I solve this equation, what's p?
And then p would be equal to 2, minus 2.
Be careful.
Uh,
How do you get rid of that 4?
Divide.
What happens when you divide 1/2 by 4?
You get 2.
No. Not multiplying
Or,
it by 4, you're dividing it by 4.
so you get 6.
You get
Wait,
1/8.
yeah, 1/8.
Well, in this
I don't know
case,
what this is.
minus 1/8.
Right, because there's a
There's a
negative.
minus sign, right. In other
Okay.
words, when I divide both sides by 4, that 4 goes over to here.
Mm-hmm.
That's dividing both sides by 4.
Okay.
This becomes 1/8. Okay.
Mm-hmm.
So we've solved the hardest thing. P is minus 1/8.
Mm-hmm.
Okay. And for this parabola, we already know it's a vertical parabola, but it's upside down. In other words, if you look at it in terms of y, there's a negative sign in front of the x squared, right?
Mm-hmm.
That makes it a vertical parabola that's pointed down. And that makes sense with the p we found of minus 1/8, because p
Right.
is always inside the parabola. The
Okay.
directrix is always outside the parabola. What's the equation of that line right there?
Y equals, +4 or positive.
What's the point of the focus?
That point was, -1/8.
What's
No,
the x coordinate of that focus?
0.
What's the y coordinate of that focus?
0.
No. We just
Or no,
figured
that's
out that
minus.
p was minus 1/8.
Right. So that it's 0 minus 1/8.
All right. Okay.
Okay.
So that's the coordinate. The directrix is always the same distance in the other direction from the vertex. So what's the
Okay.
equation of that directrix?
So the equation would be, so it'd be y is equal to -1/8.
Is it minus? Does it look minus?
Yeah. Huh?
No, it's on the plus side of that x-axis.
So it's, yeah, so it'd be plus.
Plus 1/8.
Right.
It's just
Okay.
the same distance.
Okay,
In other
that
words,
makes
this
sense.
is the origin. Well, my line is on the plus side of that origin.
Right.
It's got to be plus, and as all we know is that the distance from the vertex to the directrix is the same as the distance from the vertex to the focus.
Okay.
And one last question, what is the equation of the line of symmetry? That last red dotted line that I just drew, that vertical dotted line.
That one would be x is equal to 0.
You got
Okay.
it. That's parabolas, the short lesson on parabola.
Okay.
And that, you'll notice that we only covered parabolas whose vertex was at the origin.
Right.
It gets tougher when you start looking at equations of parabolas that are like this.
Mm-hmm.
Because now it's going to no longer be 4p, it's going to be 4p times y minus k equals the quantity x minus h squared. So that becomes your general format, and whatever your function looks like, you got to make it look like that.
Okay.
Okay? So it gets considerably harder. It's pretty easy when it's at the origin. And every problem we did tonight, the vertex was at the origin.
Okay.
So these are going to be harder when you get to those, if they give you those. They may not. In algebra 2, most conic problems, especially the harder ones, you don't really get until pre-calc.
Right.
In algebra 2, so they may only give you problems where it's at the origin. Just as a, the primer in conics. So.
Right.
All right, Dylan, the key with conics is memorize those general formats.
Okay.
If you don't know the general formats, you got no shot. And I mean that 100%. If you get the general format wrong, you're not going to get the problem right.
Okay.
And if they give you a cheat sheet, fine, you don't have to memorize them. But if they expect you to memorize them, then you got to memorize them.
Yeah, for sure.
There's 2 for each. There's 2 for parabolas. There's 2 for ellipses, because you can have horizontal ellipses, you can have vertical ellipses. Same with hyperbolas. So there's a lot to memorize with conics.
Okay.
And there's no shortcut to it. You just got to memorize it. So.
Okay.
All right. I still have you down for 5 on Wednesday. Is that something you maybe want to change permanently? Because you've changed most of them to a later time.
Yeah, let's just do that.
You make it at 8 instead of 5 on both Mondays and Wednesdays?
Sure. Yeah, let's just do that.
Okay.
Okay. It's just easier like that because they schedule practice on us. I mean, we only have 3 weeks left, so they're kind of...
Okay. Well, if at the end of 3 weeks you want to go back to 5, if it's still open, I can certainly do it. But as long as you're generally going to be practicing at that time period, let's get it moved up.
For sure.
I will see you Wednesday at 8.
That sounds good. All right.
Bye-bye.
All right, cool. Bye-bye.